Hello and welcome to the CM Educators with MWALIMU JUMA. Remember, if you haven't subscribed, subscribe and hit the like button and also the notification button to get our new video. Yes, today we are looking at chemical families. Now, chemical families, as we understand that a family is just made up, has some things that will make them to be common. How some things, the things that make a family to be common, just as the human individual families, they have something in common that make them to be called a family. Now also in chemicals or in chemistry, you have chemical families, and these chemical families have some characteristics or some properties that make them to belong to one family, Now we'll be learning about the properties that make them to be called a family. Now we'll have patterns in properties that make them to be called a family. So elements in the same group are said to belong to the same chemical family. Now we are using the group. Trends in physical and chemical properties provide useful information in predicting the physical and chemical behavior of the elements within a family. So now we look in patterns in properties. Now we are saying that elements in the same group are said to belong to the same chemical family. Remember, we say that elements will belong to the same family because in the outermost energy level, they have same number of electron. They have same number of electron in the outermost energy level. Then trends in physical and chemical properties provide useful information in predicting the physical and chemical behavior of the elements within a family. So we look at different families. The first family that we are looking at is the alkali metal. So the alkali metal elements in group 1 of the periodic table are called the alkali metals. So we say these are lithium, sodium, potassium, rubidium, calcium, and francium. But at this level, we are only looking at the first three. The first three are the one that we are looking at. The first three are the one that we are looking at. So we are saying that the elements in group 1, remember we say that a group we write using a Roman number, so the alkali metals. Now the elements in group 1 of the periodic table are called alkali metals. These include, say, lithium, sodium, potassium, rubidium, calcium, and francium. But we are only basing on lithium, sodium, and potassium. The electron arrangement of the first three alkali metals are as follows. You have lithium 2.1, you have 2121, sorry. You have sodium 281, you have potassium 2881. So you say that they have something in common. Now we are saying that in a group, the elements in the same group will have same number of electrons in the outermost energy level. As you can see here, all the three, or the entire group have one electron in the outermost energy level. So each alkali metal has one electron, in the outermost energy level. Each alkali metal has one atom, one electron in the outermost energy level. Down the group, there's increase in the number of occupied energy level. You can just see from what we have here. Now lithium has 2 energy levels, 2, 1. Sodium has 3 energy levels. Potassium has 4 energy levels. So we are saying that down the group there is an increase in the number of occupied energy levels. There's increase in the number of occupied energy level. Now let's look in the gradation of the size, gradation in size of the atom and ion. Remember we said for an ion to be formed, there is either losing or regaining of electron. Now you're looking at the gradation in size of the atom and ion. So we say that it is not possible to measure. It is not possible. Remember when define what an ion is, we said when we define what an ion is, what an atom is, we said it's the smallest particle of an atom that can take part in a chemical reaction. Smallest particle. Now it will be impossible to measure the size of the atoms and the ions, the elements in the laboratory due to their small size. Now we have here a table. Due to their small size, the table below gives a summary of the atomic and ionic radius of the radii of the alkali metal. Now because the atom is so small, remember the atom is so small, and now the ion is losing an electron. The atom is losing an electron to form an ion. So the ion is more smaller. So it will be impossible for us to measure their sizes. But now here, the radius, we are talking about the atomic radius and the ionic radius. Remember, radius, it is the length from the center to the perimeter, or to the end, from the center to the end of that atom or that ion. Now we have lithium. Now when you look at the atomic radius of lithium and the ionic radius, you'll find that there is a decrease because it is losing one electron. Now here is what happened. After the losing of one electron, the remaining electron come more into contact. Now they are held together. They are held more together, as you can see that now we are losing one electron. Now the ionic radius is smaller compared to the atomic radius, all because we are now losing an electron to form the ion. Now the ionic radius also increases down the group. The atomic radius increases down the group, because we are saying that when from one element of this group 1 to the other, there is an additional energy level. There is an additional energy level. Now, atomic radius say that atomic radius is the distance between the center of the nucleus. Remember, nucleus now is the region at the center that has the protons and neutrons. Now it is the distance between the center of the nucleus of an atom and the outermost energy level occupied by an electron or electrons. Remember, you will find that in some atoms, it is either an electron in the outermost energy level or given number of electron. So now it is the distance from the center to the outermost energy level covered by the electron or electrons. Covered by the electron or the electrons. Covered by the electron or the electron. Now let's look the trends in the atomic and ionic radius. Now we want now to explain the trend in the atomic and the ionic radius. Trend in the atomic and the ionic radius. Remember, for group 1 elements to form an ion, they lose an electron to form an ion. They lose an electron to form an ion. Now the trends in the atomic and ionic radius. The ionic radii or the atomic radii and the ionic radii of the alkali metals increase down the group. This because each alkali metal has one more occupied energy level than the preceding member in the group. Now lithium has 2 energy levels, sodium has 3, while potassium has 4. The outermost electron in a sodium atom is therefore further from the nucleus than the outermost electron in a lithium atom. This explains the increase in the atomic and ionic radii down the group. The ionic radii of an electron metal is less than its atomic radius. An alkali metal forms an ion by losing the single electron from the outermost energy level. The resulting ion, which is now the cation, has one occupied energy level less than the corresponding atom. Remember now, because the outermost energy level has only one electron, and we are now losing the entire energy level. You're now losing the entire energy level, meaning that now the ion and the atom has a difference of one energy level. When an atom loses an electron to form a positively charged ion, the remaining electron experience a greater nuclear attraction. So the remaining electron will cling more together. They'll be attracted more because the force holding them, it will be more greater. Experience greater nuclear attraction. Now, because the attraction becomes because of the different charges between the protons and the electron. Remember now, we have lost an electron, and the number of electrons and number of protons are equal. But now electrons are now few, meaning that the positive charge is now less compared to the positive charge is now higher compared to the negative charge. Now, the force from the center is more as compared to the one in the energy levels. Now they'll be more attracted to the center because now we have less number of electrons. We have less negative charge. We have less negative charge. The remaining energy level move closer to the nucleus, resulting in a reduction in the radius. Now the reduction in the radius comes because now the charge, the proton charge. Remember, the proton charge does not change because they are still the same as they were. The number is still just the same. Only what is changing is the number of electrons. Now the charge has also done what? Has also reduced. Now making them to be attracted more to the center. Now let's look at the physical properties of the group 1 elements. Physical properties of the group 1 element. Physical properties of the alkali metals. Now the physical properties. you want to look at the physical properties. Let's see the physical properties. Now here you have a table for the physical properties. You have the element, how now it appears physical. Now with physical properties, we are talking about things that we can see with our eyes. Now the element, the appearance, the ease of cutting, now the melting point, the boiling point, electrical conductivity, atomic radius, ionic, and then the fast ionization energy. Remember, for alkali metals, they'll only have the fast ionization energy because they're only losing one electron. That's why we are saying the fast ionization energy, because they're only losing one electron. When we go further, we find that other atoms, they lose more than one, so they'll have the fast ionization energy, the second, and so forth. So for lithium, it is silvery white in appearance, slightly hard when cutting, has a melting point of 180 degrees Celsius, boiling point of 1330. Now it is good in electrical conductivity. Now we are saying that the atomic radius is 0.133. Now then the fast ionization energy is 520 kilojoules per mole. And then when we look at sodium, it is shiny gray, it is easy to cut, a melting point of 98 degrees Celsius, boiling point of 890. It is good in electrical conductivity. It has an atomic radius of 0.157. Fast ionization energy, it is 496. When you look at potassium, it is shiny gray also, easy to cut, melting point of 64 degrees Celsius, boiling point of 774. It is good in electrical conductivity. It has an atomic radius of 0.203. Then it has ionization energy of 419 kilojoules per mole. So those are the physical properties of these alkali metals. Now we say that ionization energy, minimum energy required, is the minimum energy required to remove an electron from the outermost energy level of an atom in its gaseous state. Ionization energy, the minimum energy required to remove an electron from the outermost energy level of an atom in the gaseous state. So that's what we are saying, that the ionization energy. So when we look at let's explain now the information in the table. Let's now explain the information in the table. The appearance, the boiling point, the melting point, the easiness in cutting, of these elements now. The first group that we are looking at. Now let's begin with the appearance. The alkali metal have a shiny metallic cluster when freshly cut. Now they'll appear to be shiny for the alkali metals when freshly cut. However, the surface quickly tarnishes. The reason as to why it is tarnishes, the first tarnishes because of reacting with air. Remember, the face will be shiny just after cutting, but after some times it will tarnish because now the metal is really reacts with the air. It's reacting with the oxygen. Now, what the coating above, the coating that makes it to be now the reaction that makes it to be tarnished, it has reacted with oxygen. Now, it will be tarnished with an oxide. Then the ease in cutting. The ease in cutting. They are soft and easy to cut. The softness and easy to cut increases down the group due to the decrease in the strength of force holding atoms together as you move down the group. Now, as you move down, you'll find that the forces holding the atoms together decrease. Now, the melting and the boiling point. The alkali metal have relatively low melting and boiling points. The melting and boiling point decrease down the group due to the weakening of the forces holding the atoms together. The strength of the forces holding atoms together depends on the size of the atom. The larger the atom, the weaker the force. The larger, the weaker the force. Thus, the atomic radius increases the forces of attraction. Thus, as the atomic radius increases, the forces of attraction between the atoms weaken. Now, because when you have a larger atomic radius or an increased atomic radius, now it will mean that now the forces are weakened, hence the decrease in the melting and boiling point down the group. Now, the electrical conductivity. Alkali metals are good conductors of heat and electricity. Now, conductivity in metal is due to the presence of delocalized electron in the structure of the metal. Since they all have one electron in the outermost energy level, their conductivity is similar. In metals, the electron in the outermost energy level move randomly throughout the metallic structure. Now remember that in the outermost energy level, now the electron can occupy any position. It moves around. Reason being, it is the energy level is not filled. So this electron can move around because it is not filled. Now it moves randomly throughout the metallic structure. Since the electrons do not remain in one fixed position, they are said to be delocalized. Now, so for the alkali metals, they have one delocalized electron. That is moving around, now making them to be good conductors of both heat and electricity. Now, fast ionization energy. Down the group from lithium to potassium, the fast ionization energy decreases. This means that less energy is needed to remove the electron from the outermost energy level of a potassium than a sodium atom. And a lithium atom. This because the effective force of attraction on the outermost electron by the positive nucleus decreases with increasing atomic size and the distance from the nucleus. Now, because we are finding it that the distance between the nucleus and the outermost energy level is somehow big, somehow large, as when you compare the lithium and the sodium. So the ionization energy of sodium will be lower as compared to that of lithium, and potassium will be lower as compared to that of sodium. So that's what makes the that's what makes it to have a lower ionization energy as we move downwards. Lower ionization energy as we move downwards. Now let's look at chemical properties. Chemical properties. Chemical properties. Chemical properties. Chemical properties. Now of this, chemical properties of the alkali metals. Now remember the first that we have seen have been the physical properties. Now how do they react? Let's look at how they react with other elements. Their behavior when they are exposed to the air. Remember we say that once exposed to the air, after some times they are tarnished. After sometimes they are what? They are tarnished. Now here we look at the chemical properties. The chemical properties of alkali metals. Alkali metal react by losing the one electron from the outermost energy level to attain a stable electron configuration. Their reactivity increases down the group. Now let's look at the reaction with air and water. Reaction with air and water. Reaction with air and water. Now, lithium, sodium and potassium react vigorously with both air and water. Potassium is the most reactive, lithium the least reactive. Remember we are saying that the reactivity increases down the group. When sodium is exposed, it reacts with moisture in the air to form sodium hydroxide. The sodium hydroxide further reacts with carbon dioxide in the air to form sodium carbonate. Now we have here the chemical equation. Our chemical equation is here. We are saying that now the sodium reacts with water to form sodium hydroxide and hydrogen gas. Then it will further again react with carbon dioxide. To form sodium carbonate. And water. So that's how sodium now reacts. With air and water. That's how now sodium reacts with what? With water. Now sodium burns in air with a yellow flame to form a yellowish white solid, which is mainly sodium oxide. Now the sodium oxide. Now we are saying that sodium burns. Now sodium burns in air to form sodium oxide. So now it is burning. Remember, it is burning with a yellowish when it burns with a yellow flame. Now it burns with a yellow flame. So the element that burns with the yellow flame is sodium to form a yellowish white solid. Yellowish white solid. When sodium burns in air enriched with oxygen, it forms mainly sodium peroxide. When the air, when the air is enriched with oxygen, now what we are forming is sodium peroxide. Yes, forming sodium peroxide. Now it's not the sodium oxide, now it is sodium peroxide. Now because it's enriched with oxygen, because it is enriched with oxygen. Now remember you say that it burns with a yellow, it burns with a yellow flame to form a yellowish white solid. White solid. Now when the air is enriched with oxygen, it forms sodium peroxide. Now potassium burns in air with a lilac flame to form a white solid, which is potassium oxide, which is potassium oxide, which is potassium oxide. Now here is the chemical formula. Here is the chemical formula for that. So we are saying that the observation made when alkali metal react with water are summarized in this table here. So you have metal, you have observation, you have the rate of reaction. Then you have the rate of reaction. Now here now we look how when this atom, how these elements react. So we are saying the metal, we have the observation, when then the rate of reaction. We have lithium. Lithium reacts. Lithium. Now remember here it's reaction between these metals and water. Now lithium floats. We are saying that lithium floats in water. Then that's what we are observing. Now we are saying what we see when it's reacting with water. A colorless gas is produced. The gas does not ignite spontaneously. They are saying the resulting solution turns red litmus paper blue. Red litmus paper blue. Now the red litmus paper is turned blue, meaning that the kind of the solution formed is now basic. Now the reaction is vigorous. The reaction is vigorous. Now sodium metal that's on the water surface as it melts into a silvery ball. A hissing sound is produced. Now we are saying that a hissing sound is produced. A colorless gas is produced, which may ignite spontaneously, and the solution formed is alkaline. Which also means that the red litmus paper turns blue. Now the reaction rate is more vigorous. Remember the first one, we say lithium, it is vigorous. Sodium, it is more vigorous. And remember when doing this kind of reaction, or practical, remember to use a surface that is somehow large. So because it is darting, and remember to use just a small piece of oxygen, of sodium metal, Now let's look at potassium. Let's look at the metal that's about on the surface of the water and melts into a silvery ball. Colorless gas is produced, which spontaneously bursts into flame. Potassium vapor burns with a lilac flame. Now the resulting solution is alkaline. Now the kind of reaction, the rate of reaction is explosive. The kind of reaction is explosive. So alkali metal reacts with water to form alkaline solution and hydrogen gas. So the resulting solution after this reaction, they are alkaline in nature. And there is formation of alkaline solutions and hydrogen gas. Now a hydrogen gas is what that is formed with a hissing sound. When you use a burning splint, it will produce a pop sound. Alkali metal react with water to form an alkaline solution and hydrogen gas. So for them all, lithium, sodium, and potassium. Lithium, sodium, and potassium. So potassium is the most reactive alkali metal. This is because the electron in the outermost energy level is loosely held by the nucleus and is easily moved during a reaction. The ease of losing valence electron increases down the group as the atomic radius increases, hence the increase in reactivity from lithium to potassium. Now reaction with chlorine. Alkali metal react with chlorine gas to form the corresponding metal chloride. The reactivity of alkali metals with chlorine increases down the group. This because of the increase in atomic radius, which leads to increasing ease to lose the electron in the outermost energy level. So when hot sodium metal is lowered into chlorine gas, the metal bursts into flame. White fumes of sodium chloride are formed. Then lithium reacts less vigorous with chlorine, while potassium reacts much more violently with chlorine than sodium, because we say that potassium is more reactive than the remaining ones. Potassium is more reactive. Now, each alkali metal combines with a single hydroxide ion to form the respective hydroxide. So remember, they also react with hydroxides. Yes, so react with hydroxide. Now we are saying that after their reaction with chlorine, we say that the potassium will react more. Now each alkali metal combines with a single hydroxide ion to form the respective hydroxide. So you have lithium hydroxide, sodium hydroxide, potassium hydroxide. This because the valency of group 1 element is 1. So when the valence is 1 and for the hydroxide is also 1, the same applies in the formation of lithium chloride, which has chloride 1, and also the alkali metals 1. Now two alkali metal ion combine with one oxide to form the corresponding oxide. This because the valence of oxygen is 2. Now for the other one is 1. Two alkali metals combine to form corresponding oxide due to their high reactivity. Alkali metal is found as free elements. They are normally found in combined state in earth's crust. Then you have now the uses. Sodium is used in manufacture of sodium cyanide for use in extraction of gold. Lithium is used in manufacture of special high-strength glasses and ceramics. Lithium compounds are used in the manufacture of dry cells for use in mobile phones, laptops, stopwatches, and zero-emission electric vehicle. Molten mixture of sodium and potassium is used as coolant in nuclear reactors. Sodium vapor is used to produce the yellow glow in street lights. Molten sodium is used as a reducing agent extraction of titanium from titanium chloride. Sodium chloride is used as a food additive. Sodium chloride